Good morning, my dear students. Welcome back to plus 2 physics class. Today we are going to discuss the topic refraction through a prism. We already studied what is refraction. Okay, what is refraction? Refraction is the bending of a light when a light is coming from one medium to another medium. Okay, in that session we discussed the refraction through a glass slab. Okay, refraction through a glass slab, but here we are going to discuss the refraction through a prism. Okay, or glass prism. Before explaining this refraction through a glass prism, what is prism? Okay, prism is an homogeneous transparent medium. It is an homogeneous transparent medium. It consists of two inclined surfaces, glass surfaces, and the angle between these two inclined surfaces is A, angle of prism. Okay, angle of prism. That is, here this angle A is called angle of prism. Okay, what is a prism? Prism is a homogeneous transparent medium bounded by two inclined surfaces, and the angle between these two inclined surfaces is called angle of prism. Okay, angle of prism, that represents as A. Okay, angle of prism A. Okay, next we are going to discuss the refraction through a prism. Okay, let us consider a prism. This is a prism A, B, C. Okay, and a light is entered to this prism, that is a PQ. This PQ is our incident light. That incident light is incident on this inclined surface. Okay, here the incident angle is represented as I1. Okay, that is the angle between this normal. This NM is a normal, and here I am taking this is F. Okay, this FM is another normal. Okay, here the angle between this incident ray and this normal is represented as incident angle I1. Okay, that is, the light is coming from air to glass, and this AB is the interface, and the angle of incidence is represented as I1, and the refracted angle, okay, the angle of refraction inside the glass prism is R1 and R2. Here this R1 and R2 are the angle of refraction. Okay, angle of refraction inside the glass. Okay, inside the glass prism. Okay, R1 and R2, or in the face AB, I1 is the angle of incidence and R1 is the angle of refraction, and the light is entered to this glass prism. Here a in angle is formed, that is another angle of refraction R2, and at this phase, okay, that is at this phase means at AC, or in the phase AC, I2 and R2 are the angle of incidence and angle of refraction. Okay, angle of incidence and angle of refraction. Okay, here this I2 is emergent angle or angle of emergence. Okay, here I2 is the emergence angle. This R2 is the second angle of refraction inside the prism. Okay, inside the prism. Okay, and here this D is the This D is the angle of deviation. Okay, angle of deviation. That is how much deviation is formed here. That will give this angle of deviation. Okay, D is represented as angle of deviation. Here D is indicates angle of deviation. Angle of deviation. Is it clear? Okay, listen here. Here let us consider a glass prism and a light is entered to this glass prism. The refraction is occurred, and here this I1 and R1 are the incident angle and refracted angle in the face AB, and I2 is the emergence angle of emergence, and R2 is the angle of refraction the face AC. Okay, and this D is the angle of deviation. That is how much this light ray is deviated. That will get angle of deviation. Okay, angle of deviation. Next we are going to derive this angle of deviation. Okay, here let us consider a quadrilateral, that is here AQMR. Okay, in this figure let us consider a quadrilateral AQMR, that is AQMR. Okay, let us consider this quadrilateral AQMR. Okay, AQMR. From this, what is angle Q? Oh, here this NM is a normal. Okay, NM is a normal. Therefore, here this Q, angle of Q is considered as 90. Okay, 90. And here also, this FM is a normal. Okay, therefore, here the angle R equal to what? 90. That means angle Q plus angle R equal to what? 180 degree. Okay, angle Q plus angle R equal to 180 degree. When since FM and NM are normal. Okay, since FM and NM are normal, angle Q plus angle R equal to what? 180. Okay, 180. Therefore, here angle A plus angle M equal to what? Angle A plus angle M equal to 180. Why? Here this quadrilateral AQMR, here angle Q equal to 90, angle R equal to 90, that is here the total 180. Therefore, angle A plus angle M what? 180. Why? The total angle is 360. Okay, total angle is 360. Here this angle Q plus angle R equal to 180. Then angle A plus angle M equal to what? 180. Okay, putting this is equation number 1. Equation number 1. Then from triangle QMR, or let us consider this triangle QMR. From this triangle, R1 plus R2 plus angle M equal to what? 180. Okay, that is from triangle QMR, angle or R1 plus R2 plus angle M equal to 180. We have the sum of angle of a triangle is 180. Okay, sum of angles of a triangle is 180. Here let us consider, or here we considered the triangle QMR. Angle Q equal to R1, R1 plus R2 plus angle M equal to what? 180. Okay, 180. Taking this is equation number 2. Okay, equation number 2. Comparing equation 1 and 2. What will get? From this we get R1 plus R2 equal to R1 plus R2 equal to triangle A. Sorry, angle A. Angle A means angle of prism. That is R1 plus R2 equal to A. Putting this is equation number 3. Okay, this is equation number 3. Clear? Then next we consider another triangle, triangle QRT. This one, QRT. Sorry, here this is T. Okay, QRT. From this triangle, that is from triangle QRT, the angle of deviation D equal to, this angle of deviation D equal to the deviation at the face. First, deviation at the first phase, plus deviation at the second phase. Okay, here this D means what? The deviation. Okay, angle of deviation, that is the angle of deviation in the first phase and the angle of deviation at the second phase. Okay, second phase, that's equal to what? Here the deviation is, here this angle is R1 and this is I1. Okay, this is I1 means this total angle is I1. Okay, opposite angles. Okay, I1. That means this angle is considered as what? I1 minus R1. And this is I2 minus R2. I2 minus R2. This angle is I1 minus R1. This is I2 minus R2. Okay, I2 minus R2. Therefore, here the D equal to, deviation D equal to, what is the deviation at the first phase? Here this is the deviation value, that is I1 minus R1 plus, what is the second deviation value? This is I2 minus R2, that is I2 minus R2. Okay, I2 minus R2. Okay, just simplifying this. It is I1 plus I2 minus R1 plus R2. Okay, that is here I1 plus I2. What is R1 plus R2? R1 plus R2 equal to what? A. Okay, that is minus A. That is D equal to I1 plus I2 minus A. I1 plus I2 minus A. Clear? Okay. Okay. D equal to I1 plus I2 minus A. This is the equation for angle of deviation. Okay, angle of deviation. While we are doing this experiment in a lab, we get the angle of incidence. Okay, the angle of incidence increases if the angle of incidence increases, the angle of deviation decreased. Okay, if the angle of incidence increases, that time the angle of deviation decreased. Okay, that is, let us observe a graph. This is a graph related to this thing, that is, this is the angle of deviation and this is our incident angle, and the graph will get from that experiment like this. Okay, that is inversely proportional. That is, if the incident ray, if incident angle is increased, that time the angle of deviation is decreasing. At here the minimum point of this deviation is called angle of minimum deviation. This is the minimum value or the minimum deviation. That minimum deviation angle is called angle of minimum deviation. That is represented as capital letter D. Okay, capital letter D. Clear? Okay, and one more thing. In the case of minimum, I1 equal to I2 equal to I, and R1 equal to R2 equal to R, and D equal to capital letter D. That is the case of minimum, or at the minimum deviation portion. At the minimum deviation portion, I1 equal to I2 equal to what? I, and R1 equal to R2 equal to what? R. Okay, and D, the angle of deviation equal to what? Minimum deviation. At that time, what is the equation? Third will change to, we have R1 plus R2 equal to what? A. From this, R1 equal to what? R. R2 equal to R. That is, R plus R equal to 2R equal to A. That is, R equal to what? A by 2. A by 2. Similarly, the fourth equation becomes, this is third equation, taken as fifth equation. Okay, what is fourth equation? Fourth equation is D equal to I1 plus I2 minus A. Here I1 and I2 equal to I, that is, this is 2I minus A. 2I minus A equal to D. Okay, that is I equal to, what is D? D equal to capital letter D. Okay, D equal to capital letter D. That is A plus D by 2. So I equal to A plus D by 2. Okay, then what is the refractive index? According to Snell's law, we have the refractive index N equal to sin I by sin R. Okay, the refractive index N equal to sin I by sin R. Here substituting these two equations, that is fifth equation and sixth equation, what will get? Sin, what is I? I equal to A plus D by 2. A plus D by 2 divided by sin R. R equal to what? R equal to A by 2. R equal to A by 2. This is the equation for refractive index. Okay, that is, from this session, refraction through a prism, we studied what is angle of deviation and angle of minimum deviation. Okay, and the third one is refractive index in the case of a glass prism. Okay, refractive index of glass prism, N equal to sin A plus D by 2 by sin A by 2. Here A is the angle of the prism. Okay, angle of prism, and D is the minimum deviation. Okay, minimum deviation. Clear? Okay, this is the refraction through a prism. Okay, I hope you all are understand this session. Okay, thank you.